Good day, students, and welcome to the last video covering the study guide of digits 1. Now let's get straight in. It's for and or invert ICs for SOP expressions. So AOI for sum of product expressions. So as you go from sum of product expressions, the logic circuit consists of AND gates feeding into a single OR gate. For example, you have this, which is a sum of products. This is then referred to as AND OR logic. And then sometimes when playing AND OR invert gates, SOP expression are not in the standard form. But because SOPs are used so often, they have made specific ICs that you can use to implement an SOP circuit. So this then means you can use one IC for this expression. We can use one IC instead of using an AND IC, OR IC, and an invert IC. So just for this specific section, we're using older symbols. This symbol is for AND, this symbol is for OR, and this symbol is for NOT. It just makes it easier to show the principle of the working of the ICs. So the first IC we have is a 74S64. It's a 4 wide 4232 AND OR invert gate IC. It consists of 4 AND gates, 4 wide, one of them with 4 inputs, one with 2 inputs, and the remaining one with 3 inputs. So you have 4 inputs, 2 inputs, and 3 inputs. All the AND gates are ORed together, which makes it an SOP expression, but the final output is inverted because of the bar across the expression. So here you have the AND gate, a 4 input AND gate, a 2 input AND gate, a 3 input AND gate, and another 2 input AND gate. So this is the 4232, and then these AND gates are all together, and then it's inverted. Like so. And this is the pin layout for the IC. You have your inputs from A to Y, VCC up to the right, and ground on the left. And now here we have 34LS54 4Y2332 and or inverter gate. So the IC consists of 4 AND gates, 2 with 2 inputs and 2 with 3 inputs in the sequence 2, 3, 3, 2. So it's exactly the same as the other IC. You have your AND gates, OR gates, and then it's all inverted. Okay, so this is the OR part of it, and then that's inverting it. And this is the IC exactly like the other one, just you have no connection down here. And now you have your 70LS51 and or invert gate, AOI, and it consists of a 2 wide 3 input and a 1 2 wide 2 input and or invert gate. The IC has 2 outputs, Y and 2Y, as shown in this logic expression. These 2 outputs are entirely independent from one another. So this is the expression for the one output, and this is the expression for the other output. So you have 2 outputs. So this is the logic symbol diagram. You see you have 2 outputs, and here you have the AND gates and the inputs feeding into the AND gates, and you have the inputs feeding into the AND gates. They're being ORed together, and you have your 2 separate outputs. And this is the logic diagram. So you have AND gates, OR gates, and then it's knotted. And it's the pinout. So for the one denotes the one input, and 2 is the other outputs, other inputs, and then 1Y is one output, and 2Y is the other output. So okay, cool. So now we've done it. How do we use it? So we do activity 7.1. So we have a logic expression, which is given here, and we want to express it. by using an AND or inverter, just one IC. So here we have A, not B, not D. So we use the first AND gate. So we have A, not B, and not D. And the other gate we just leave open. Well, we connect it to VCC. Sorry, we connect it to VCC. So it's a 1. Second gate we have A, and then not B. And then the third gate we have B and D. And the other output is 1. And then we have C, and the other output is 1. And these are all ORed together, which we have over there. And that is how you use these ICs. Specifically, look at what IC you are using, and then look how it works, and then just connect up the ICs as in the logic equation. And that is it. And well, that was the last video on the study guide, and I wish you all good luck.